Hi GOR, this is lesson 6, and today we're going to talk about the base angles of isosceles triangles. So remember, isosceles triangles have two sides that are congruent, and what we're going to do in this first exercise is we're going to prove that the base angles of those isosceles triangles are congruent. So when I have an isosceles triangle, the two sides are congruent. These two base angles, where I'm putting the two dots, also are congruent, and that's something that we've talked about before, but now we're going to actually prove that it is true. So in the first example, given isosceles triangle ABC with AB congruent to AC and AX bisects angle BAC. So I'm taking angle BAC and I'm bisecting it. I want to prove that angle B is congruent to angle C. Step 1 is to prove that the triangles are going to be congruent to each other. So basically triangle ABC has been split into two triangles. So the outermost triangle ABC is isosceles, but that line X is dividing it into two triangles, and we're going to prove those two triangles are congruent to each other. So I have isosceles triangle ABC. AB is congruent to AC, and AX bisects angle BAC, and that's all my given. So I marked AB and AC congruent. If AX bisects angle BAC, that means it's cutting angle BAC in half, and I'm going to number those angles 1 and 2 and say that they are equal to each other. Why are they equal? Because an angle bisector divides an angle into two congruent angles. But I'm just going to write definition angle bisector. I don't have to write out the whole definition. Now these AX is also shared in both triangles. So whenever they share a side, I say that side is congruent to itself. AX is congruent to AX. Remember, I'm trying to prove that these two triangles are congruent to each other. So something is always congruent to itself by the reflexive property. And now I have enough to say the two triangles are congruent. So the triangle on the left, BAX, is congruent to the triangle on the right, CAX. And the reason is side angle side. Notice I have two sides and I have the angle between them. Now what are all the corresponding angles and sides? That's what step 2 is asking us to say. Well, the angles are pretty easy. Angle B is congruent to angle C. This will be a little bit harder because I have to use the three letters. BAX. Well, actually, I'm going to take that back. I'm just going to call that angle 1 and angle 2 because I already have numbers there. So why not? Angle 1 is congruent to angle 2. Okay? And I can even put numbers here, 3 and 4. And angle 3 is congruent to angle 4. So those are my corresponding angles. And my corresponding sides are BA congruent to CA, and that one I already knew from the given. AX is congruent to AX. Both of them have AX in them. And then on the bottom, BX is congruent to XC. So those are all my corresponding sides. Once the triangles are congruent, all of the corresponding sides and angles are going to be congruent. So angle B and angle C have to be equal to each other. Okay, they are corresponding angles, and I know those triangles are congruent to each other. The reason that they're congruent is Cpctc. Corresponding parts of congruent triangles are congruent. And we talked about that in an earlier lesson already. So now we're bringing that back. What type of angles were formed when the angle bisector intersected BC? What does this mean about the angle bisector? So basically, angle 3 and angle 4 are also equal to each other. That means that since they form a line and they're equal to each other, they must be right angles. Therefore, that angle bisector is also a perpendicular bisector. So it's an angle bisector at the top, and it's a perpendicular bisector down at that bottom. So the angle bisector is also a perpendicular bisector. And the bottom here is just saying what I've already said. Once we prove the triangles are congruent, we know that their corresponding parts, meaning their angles and sides, are congruent. We can abbreviate this in a proof by using the reasoning of Cpctc. Corresponding parts of congruent triangles are congruent. Remember, we always first say that the triangles are congruent which I did in step 4. And then step 5, I can just say angle B is congruent to angle C, and that reason would be Cpctc. So I'm going to be doing some more Cpctc proofs today. And at the same time, I just proved that these base angles here, angle B and angle C, are equal to each other. So once the sides of a triangle are congruent, then those base angles are congruent to each other. So to prove angles or sides are congruent right here, first prove the triangles are congruent using the one of the above, so either side angle side, side side side, angle side angle, angle angle side, or hypotenuse leg. Prove the triangles are congruent, and then you can say that any of the rest of the corresponding sides or angles are congruent. And that's written right here. Then you state that the angles and sides are congruent because of Cpctc. So that's what I got on the next page. Sorry about that. To prove something's a midpoint or a bisector or perpendicular or parallel, I still prove the triangles are congruent. Then I state whatever angle or side I need to be congruent. And then I can say that those are either a midpoint or a bisector depending on what it is I'm trying to do. All right, so let's look at an example together. So again, I have isosceles triangle ABC with angle A as a vertex angle. So I got statements on the left, reasons on the right. All right, got all my given. So isosceles triangle ABC, angle A is a vertex. So basically when they tell me angle A is a vertex angle, that's telling me that those are your two congruent sides, and I'm going to write that down. But let me finish my given. D is the midpoint of BC, is all my given. So by knowing that A is that vertex angle, if A is a vertex, then that makes AC congruent to AB. And that's just my definition of isosceles triangle. In the given, they told me it was an isosceles triangle. An isosceles triangle has two sides congruent. Boom, those are my two congruent sides. All right. D is the midpoint of BC. If D is the midpoint of BC, it cuts BC in half. See how I have D is the midpoint of BC. So I already marked it. Now I'm going to write it as a statement. CD is congruent to DB. Definition midpoint. So I have two sides so far. And look at this. They share that side in the middle, AD. So AD is congruent to AD. Reflexive. All right. And then I can say that my triangles are congruent to each other. Because look how you've marked your triangle. You always want to be marking the triangle so you know when you're done. So the triangle on the left, triangle CAD, is congruent to the triangle on the right, triangle BAD, and the reason is side, side, side. Now once the triangles are congruent, all of the other remaining corresponding parts are congruent. They wanted me to prove that CAD is congruent to BAD. Well, CAD is right here, and BAD is right there, and they are congruent. Once I know the triangles are congruent, I can say the rest of the corresponding sides or angles are congruent, and that reason is just Cpctc. Corresponding parts of congruent triangles are congruent. It's basically 3 C's with the PT between the 3 C's. All right, and then this last one right here. Given isosceles triangle ABC, AD bisects CAB. So I'm bisecting this angle, and I want to prove that D is the midpoint. So I got my statements on the left, and I have my reasons on the right. Oh, that's AD bisects angle CAB. So it's the same picture, but you're going to see my statements and reasons are different because my given's different. Now I know it's isosceles, so that means that these two sides are congruent. That's going to be exactly the same. CA is congruent to BA. Definition of isosceles triangle, so that's the same. But in this particular proof, I have an angle bisector. If I'm bisecting angle CAB, that means I'm cutting angle CAB in half. So put numbers where the angles are the angles that cut in half. I now have two angles, and those two angles are congruent to each other. So I just put numbers 1 and 2 there, and I say angle 1 is congruent to angle 2, and the reason is definition angle bisector. Okay. And then I look at my picture and I say, oh wait, they share that side in the middle. So that's a step. All these proofs are partial credit, so you get points for every step that you can get. Try and write as much as you can. So they share that side in the middle. AD is congruent to AD reflexive property. Now ultimately, I'm trying to prove D is the midpoint. But in order to prove D is the midpoint, that would mean that, let me get a different color, that would mean that CD has to equal BD. If D is the midpoint, then that would have, those two orange segments would have to be congruent. The only way I can get those orange segments congruent is if the triangles are first congruent. Are the triangles congruent? Well, look at my picture. Yeah, I have side angle side. So I'm going to say triangle CAD is congruent to triangle BAD by side angle side. Once the triangles are congruent, the rest of the corresponding sides are congruent. So let's say that those two sides, CD is congruent to BD. Now, why are they congruent? By Cpctc. Once the triangles are congruent, the rest of the corresponding sides and angles are congruent. So now I've said that CD is congruent to BD. And if that's true, then that means that D really is the midpoint, and that's what I'm trying to prove. D is the midpoint of BC. Reason, definition, midpoint. So I first prove the triangles are congruent, then I can prove the corresponding sides are congruent, and if those sides are congruent, then that makes D a midpoint. All right, I'm done with the proof when I prove what they asked me to prove. So we'll practice a little bit this tomorrow, but not necessarily with the proofs, just with the isosceles triangle and setting those